AVL deletion. First, let's define the AVL tree. AVL was invented by two Soviet inventors, namely Georgy Anderson Belsky and Evgeny Landis. The first letter of their surname was used, where A and B stands for Anderson Belsky, L stands for Landis. But the real question here is, what is AVL tree? AVL tree is a self-balancing binary search tree, BST. The difference between the heights of left and right subtrees cannot be more than 1. So in that case, the difference is 2 or more than, balancing must be done. We have this notation where the height of an AVL tree is always 0 log n. Take note that in 0 log n, the n is the number of nodes in the tree prior to the operation. AVL deletion. There are two ways to perform an AVL tree. It is by insertion and deletion. But in this tutorial, we will focusing on performing an AVL deletion.
Performing an AVL deletion is pretty simple. We can perform a standard BST deletion of the node that rebalance the BST by left and right rotation. If the tree is not balanced after performing standard BST deletion, the following 4 cases might occur. The number 1 is by left-left case. Number 2 is by left-right case. Number 3 is by right-right case. And the last one is by right-left case. So let's now proceed to the actual AVL deletion process.
So I'll be demonstrating to you the AVL deletion process. Here we have to delete the numbers 22, 16, 0, 5, 60, and 30 on our AVL tree. Here is our AVL tree that I prepared. Now what we have to do is to delete the numbers that I mentioned. Now let's proceed on knowing if this AVL tree is balanced or not balanced. To know that, you have to get the balance factor of each node. Here is the balance factor of each node. So to get that, you have to get the difference of the left child and the right child. So left minus right. So here 16 has 0 minus 0, so the balance factor is 0. Supposedly this is 1, but I forgot to include it. So the balance factor of 18 is 1, so still balanced. Here 0 on the left and 0 on the right, so 0. Same as other node, that's what you're going to do. You need to subtract the left child and the right child. Now let's proceed on deleting the node 22. Here on our AVL tree, we have just deleted the node 22. So let's get the balance factor of this AVL. Let's know if this is balanced or not balanced. Here 0, balance factor of 16 is 0, so then 18 is 0 minus 1 minus 0 is 1, then 20 on the left 1, 2, then on the right 0, so 2 minus 0 is 2. We will consider this sample as not balanced. For an AVL tree to be balanced, it has to have a balance factor of between 0, -1, and 1. Any numbers more than 1 and -1 is not considered as not a balanced tree. What we have to do is to balance this AVL tree. What we have to do is to balance 16, 18, and 20. But before that, we have to remove the rest of the node, not including the numbers that we need to balance. So there you go, 16, 18, and 2 is now prioritized. In this case, since this is a left child and another left child, so this is a left-left case. Our rotation, since it's a left-left case, this will be a right rotation. 18 and 20 will be rotating to the right. 18 will be the parent and 20 will be the child. Here is the final rotation where 18 is the parent and 16 is the child. And 20 is the child also. Now, let's see if this is already balanced. So 16 and there's no child, so left 0 minus 0 is 0, then 18, 1 on the left and 1 on the right, so 1 minus 1 is 0, so this is balanced. Now we have to include 18 and 16 and 20 on our AVL3. We need to put it back on the AVL3. There you go. We already deleted 22 on our AVL3. And let's see if this is balanced again. Since this is balanced, you can now proceed on deleting the next number, which is 16. There we have deleted 16. Let's see if the AVL3 is still balanced. Since the AVL3 is still balanced, there will be no rotation that will happen on this scenario. So you can now proceed on deleting the next number, which is 0. Now, we will have to delete node 0 on our AVL3. Here we have already deleted the node 0. So let's see if our AVL3 is still balanced. Here we already calculated the balance factor of each node, having a 0 and 1. So no rotation will happen on this deletion process. So you can now proceed on deleting the node 5. Here you can see that we have already deleted the node 5. Now, what we need to do is to calculate the balance factor of these three to know if this is balanced or not balanced. Since 15 has no child on the left and has 2 child on the right, so the balance factor of 15 is 0 minus 2. And we've got the negative 2 as a result, but we have to get the absolute value of negative 2. So the balance factor of 15 is 2. So this is not balanced. So what we have to do is to balance these numbers to make sure that this tree is still balanced. Now we have removed the rest of the nodes just to prioritize these numbers. So we have to balance these numbers. Since 15 has a child on the right and 18 has a child on the right, so this case will be a right case. Our rotation will be a left rotation. Here you have to rotate 18 and 15 going to the left. So 18 will be the parent and 15 will be considered as the child of 18 and 20 as well. Here is the answer. Now let's get the balance factor and know if these nodes were balanced already. Now that this is balanced, we can now combine it again to our AVL3 and check if the AVL3 that we had is still balanced. Just like I mentioned earlier, we already deleted the node 5, so we did balance already the numbers 18, 16, and 20. So let's calculate the balance factor again of each node to check if this AVL3 is still balanced. Our AVL3 is still balanced. Now we have to delete node 60. Here we have already deleted the node 60. Let's check if our AVL3 is still balanced. Calculating the balance factor of each node, and there you go. Our AVL3 is still balanced. Then you can now proceed to the last node, which is 30. What we need to do here is to delete node 30. So let's see if what will happen. Here I have already deleted node 30. Let's calculate the balance factor. And there you go. 50, 55, and 52 is not balanced since 50 has 2 childs. What we have to do is to rotate these numbers to make the AVL3 balanced. Don't mind this number, I just typo. Remove the rest of the node just to balance these 3 numbers. Since our parent 50 has a right child and 55 has a left child, so in this case our case will be a right-left case. So our rotation will be a left-right case. Here we have rotated 52 and 55 to the left, but it's still not balanced. So let's now proceed on the next rotation. So since we've already rotated 52 and 55 to the left, now let's consider this as a right case. So our rotation now will be a left rotation. Here is our nodes, which is the 52 as our parent, and 55, this is 55. Let's check if this is balanced. Since 52, 50, and 55 is balanced, we may now proceed on combining it to our AVL tree. So we have already deleted 30. Now let's check if this tree is balanced. There you go. We've just calculated the balance factor of each node, and we have 0 as the balance factor of each node. And there you go. This is the deletion process. I hope you enjoy and learn on how does the deletion process was done. Yeah. Thank you.